Hello and welcome back to another episode of Math with Sohn. Today we're going to be going over the entire unit for zeros of polynomials. So the first thing we have up on the menu is synthetic substitution when x is equal to -4. Synthetic substitution just means that you put the -4 on the outside. You do not change the sign of it. You take all of these numbers. You put them here. If you're missing any terms, you need to make sure you include them. You bring down the first number, -5. We multiply, we get 20. We add, we get 1. Multiply, -4. Add straight down 3. Multiply -12. And add, you get -1. With synthetic substitution, your only concern is that last number, and that is what would happen if you were to plug in -4. So your answer to this is quite literally f of x or whatever equals -1. The -1 is the answer. Okay? Next one, write a polynomial of least degree with the coefficients of 2 and 3i. For this problem, we are going to start with our factor of x minus 2. And then we're going to have another factor, which is x minus 3i, changing the sign, but also x plus 3i because imaginary numbers always come in pairs. Okay? I would highly recommend that you FOIL the first imaginary part like together first and FOIL that. If you do that, you get x squared minus 3ix plus 3ix. And then 3i times 3i would be 9i, but it's a -3i, so it's a -9i squared. From here, that middle chunk will cancel every single time, which is nice. And we get x squared -9 times -1 makes +9. And the x minus 2. Now, if you're in Algebra 2 Standard, your teacher may ask you to stop there, including myself. My honors students, however, I am expecting them to FOIL this out as well, which would give us a final answer of x to the third from x times x plus 9x minus 2x squared and then minus 18. And if it were multiple choice, they would probably flip-flop those two because they're in like not descending order. So it should probably be the -2x and then the 9x and then the 18. Next one. We are finally finding all the roots. Anytime you are asked to find all the roots, you need to find your handy-dandy graphing calculator. Mine's on a different table. And you graph it. That's the first step, is to graph the thing. So you graph it, and you just see what happens. So x to the third plus 6x squared minus 7x. Graph. This one is an easy problem because it goes through 1, 2, 3 zeros seemingly perfectly, and we just have to write them down. We know that that is the only zeros that it will have because if I look at it, it has an x to the third, and I had 1, 2, 3 perfect zeros. So the question is, what are they? This one is at -1, 2, 3, 4, 5, 6, 7. I hope. Yep, 7. So -7. The other ones are at 0 and 1, and those are a little easier to see. So I write them down, 0, 1, and I am done because they all went through perfectly, which is rare if you're using a graphing calculator because that's just a little too easy. This next one I'm betting is not going to be so easy, so we're going to graph this next one. Y equals 5x to the third plus x squared minus 5x, and then -1, graph. Doop-de-doo. So this one has also zeros that are perfectly -1, 0, and 1. -1, 0, and 1. No dividing necessary to find those because they all look like they go through nice and perfect. Eventually, we're going to have a rough one. And here it is. Find those zeros. 1 0 has been provided. The 1 0 that has been provided is a 1/3, which tells me that off the bat, like this is probably not going to be great, but it's also a 15x to the fourth. So that 1 0 is not going to even be enough. We are still going to have to graph this to see what's going on. So I'm graphing it down here, 15x to the fourth minus 2x to the third minus 16x squared plus 2x plus 1. Graph. Okay. So it looks like it has a 0 at -1. It looks like it has a 0 at +1, and then it looks like it has two of these that we don't really know. Okay, so for this, you should probably resort to dividing because we don't have all the zeros. I'm going to start by dividing with a 1 because it looks like it goes through at 1. I'm going to write these numbers here, 15, -2, -16, 2 and 1. Bring down the 15, multiply, add, multiply, add, multiply. I'm tired of multiplying and adding. -1, 0. Hooray. But because this problem started with an x to the fourth power, we're only at x to the third. So even though we've divided, we need to divide again with another 0 that went through perfectly. Now, you're welcome to use the 1/3, but if you have a graph and it shows you that it goes through at 1 and -1, you might as well use -1 instead because, by all means, that's a little bit easier than 1/3. Multiply, add. Oop, almost messed up. There we go. So now I'm at 15x squared minus 2x minus 1. And I need to find the remaining zeros here, which could mean I have to use the quadratic formula, but it also could mean that I would have to factor. In this case, I am pretty confident that it will factor, so I'm going to try that. 15x squared, -1, -2x, multiply these together. What multiplies to 15 that adds to 2? Well, that's 5 and 3, everybody. And the 5 would be negative. And then we have a 5 here because that would actually go into 15, and a 3 here because it would go into 15 and multiply to 15. And the 3 belongs with 3, and the 5 belongs with 5. -1, +1. We end up with 5x plus 1 and 3x minus 1, which explains why we had a 0 of 1/3 given to us. But it doesn't really explain how we had the 0 of -1/5 that we didn't know until just this moment. All right? Keeping it going. We got this one right here, find all the zeros. It just says then find all the zeros. Oof. Bad. Type it in the calculator. X to the third minus 7x. Type it better to the third. Minus 7x squared. Then minus 10x, then plus 66, graph. Ooh, nice, not so nice. So we're going to have to do the same exact thing where we have two zeros. We get to pick one of them. If I pick one of them, I am going to pick positive 1, 2, 3. So I'm going to pick positive 3. I'm going to divide 1, -7, -10, 66. And see what happens. And it looks like it's going to give me a remainder of 0. From here, it went from x to the third. Now it's at x squared minus 4x minus 22, which I also think will factor. And if it factors, hooray, because then I don't have to use the quadratic formula. I promise you, on your test, you will probably have the quadratic formula at some point, though. What multiplies to -22 but adds to -4? Anything? Oh no. Does it not factor? I don't think it does, which would make me sad. So I don't think this one factors. I don't think anything multiplies to -22 that adds to -4. It looks like it should have, but I don't think it does. So if that's the case, I'm going to resort to quadratic formula. -b plus or minus the square root of b squared, which would be 4 squared, -4 squared technically, minus 4 times 1 times c, all over 2a, all over 2 times 1. Let's see what this does. We get 4 plus or minus the square root of 16 times minus 4 I'm typing it in the calculator. I'm struggling, though. 104 all over 2. Okay? So from here, you should try and simplify the 104. And the square root of 104, if you have a fancy calculator, is 2 square root of 26. And the reason it's 2 square root of 26 is because it's 4 times 26. So this is 4 plus or minus 4 plus or minus 2 square root of 26 all over 2. And if you divide both of those, you get 2 plus or minus 1 square root of 26. Those are the difficult zeros to find. What was the easy zero to find? 3 and 3. So that was annoying. I really thought it only had to be factored, but it didn't factor. So quadratic formula. Number 7. This one says factor completely. This is a factor by grouping problem. You could go through and graph it and then get a lot of your answers from that, but it would involve a lot of synthetic division, just so you're aware. So if we were to factor out an x to the 4th here, we would be left with x squared minus 1. And if we were to factor out a negative 9 here, I would be left with an x squared, minus 4, and an x squared minus 4. Here I'd be left with x squared minus 4 as well. Apparently I'm getting tired. So, numbers in front, we got x squared and negative 9. That would be x to the 4th and negative 9. Then the x squared and minus 4. If we were to factor this further, which we need to, we would end up with x squared minus 3 and x squared plus 3 and x plus 2 and x minus 2. All right? Now, if you didn't know how to factor by grouping, you could use synthetic division with the 2's to be able to get it down to something that would factor a little bit more easily. But it's not required if you know factor by grouping. So synthetic division would still work. You could still use the calculator, find the zeros, divide by it, get it to something that would be factorable, and end up with the exact same answer as well. Okay? I think we got one more page. We do. Oh, I'm sad. There's a total of 11 problems. Total of 11 problems. I think they're going to start going quicker. This next one is just divide. We got to divide this by n plus 10. So if I change the sign on the outside, 1, 16, 53, negative 77. 1, negative 10, 6, negative 60, 7, negative 70. And you do get a remainder. And that is because you get a remainder. Oop, it's negative 7. Oh no, that makes it positive 70. But it's still a remainder of negative 7. And that's because it's not a 0. You're just dividing for fun, for no reason whatsoever other than to have fun. We started with n to the 3rd, so this would be n squared, plus 6n, minus 7, plus the remainder divided by the original n plus 10. Woo! Write an equation given this graph. So this graph curves up back here, I believe. We have to first recognize the zeros. We have a 0 at negative 3. Not negative 3, that's positive 3. We have a 0 at 1/2 and a repeated 0 at negative 1. Okay? So the 0 that is repeated at negative 1 would be, change the sign, x plus 1 squared because it had that multiplicity of 2 when it's repeated. This 0 that is 1/2 would not be written as a 1/2. It'd be written as 2x minus 1 because you would have to change the sign but also have the 2 in here because we divided by 2. And then x minus 3. Throw a y equals, you have your equation. This is an equation for it. It's not the equation necessarily, but it would be enough for multiple choice in most situations. 2 more. State the possible rational zeros. The possible rational zeros is much, much different. You cannot find them from the graph. It is what you would do if you did not have a graphing calculator. It is the factors of the last term divided by the factors of the first term. And what we mean by factors are what can you multiply to equal it? Well, in this case, the only thing that multiplies to equal 7 would be 1 and 7. And the first term would be 2. So we are going to put 1 for 2, for 7, let's do this the right way. 7 is this, 2 is this. 2 would be 1 and 2. So we're going to put 1 over 1 and 7 over 1. So 1 over 1, 7 over 1. And then we're going to put 1 over 2 and 7 over 2. 1 over 2 and 7 over 2. And all of these get their very own plus or minus, plus or minus, plus or minus, plus or minus. Okay? This next and last question right here is, I'm not going to be doing it. It is for my honors students. This would be my honors students. I'm asking them to do a Pascal triangle, so it's there. If you're wondering why I'm not doing it, it's because it's not really in the polynomial unit, but I wanted to test it on my test for my students. My standard students, if you're watching this, we are doing a quadratic formula for number 11. So you need to make sure that you know how to use your quadratic formula and do that. All right? That's going to do it for this one. Until next time, stay positive, everybody. I will see y'all later. Bye.